Aye.
Mine is the same.
I think Tony's back.
Yeah, mine's the same.
Yeah, I'm back. Sorry.
Hi, Tony. You
Hello.
can resume.
Yeah, sorry about that. I had a
System crash.
I think my display adapters just bombed out. So my apologies, everybody.
No problem.
Nice to see you all working together in my absence. Makes me feel like I'm not needed. So I'm just going to go home and cry.
Don't think that.
No, don't worry. You still need it.
I appreciate that. I'm not that sensitive. Let me just try to open everything back up again. All right. And I wonder how much of my progress I was able to keep.
So quick question, is the first half of the video that we've recorded, are those already recorded or do we lose them?
Well, that's what I got to figure out. When this, I tried the file that survived my little shutdown was having difficulty. It asked me if I wanted to convert. I tried. I got an issue. So I'm going to see when this is done if I can salvage both those files. So I have a folder that it goes to. And in Zoom, under date modified, this is the 26th. So I've got the file in there. It's a smaller file. Double click to convert. So yeah, I'm converting that now. So this may be fragmented. We'll see. We'll experiment. We'll see what happens. And this was the Lab 5 collab. Okay, so here we are back at the original. And now we were working off of the walkthrough just to keep myself oriented properly. The walkthrough was in the lab under neural network. Okay, so I think we're reset to where we were when I lost everything. Going back up to the diagram, brought down the model comparison, did the 3, did the 16, misclassification, auto-neural, blah, 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 blah. There it is. Maximum duration is 5. Misclassification rates is there. Train, run, and we saw the results. And that's where everything crashed, was putting the results away. But the results showed the auto-neural is the optimal model, has the lowest misclassification rate. So then on to the next part, which was looking at the classification table. So after we get our confusion matrix and our
Tony, your screen is not. I don't think you're sharing the other screen.
No, I'm on the side screen. If I bring my results down and go to the view assignment classification chart, this shows us the 3 nodes, neural network 3, 16, and the auto-neural. And it shows the auto-neural has the highest percentage of accuracy and the smallest proportion of incorrect data. So that's number 17 on the walkthrough. And then it talks about number 18, about this lift, this ROC chart, and how the auto-neural has the highest lift on the chart. So then it tells us to close that model. or close that model comparison node. And the next portion says, it talks about comparing the neural network models to the decision tree model. So this is where we're gonna join them. And in joining them, they want us to delete the model comparison nodes that exist and then bring in a new model comparison node from the assess. And we're going to link all three neural networks, and we're going to get rid of that control point. And we're going to bring in the decision tree nodes, and then we're going to realign. And then for the properties of the misclassification, we're going to change the selection statistic to misclassification rate. And it says to not change the selection table, so we're going to keep that train. And we're going to update and run. And this should give us the 6 different nodes as the result. It's happening, I promise you. We're getting there. So close. Okay. So now looking at our results, we have our 6 models, our 6 nodes, autoneural, neural 2, neural, and then the trees. So and I can never get this thing to, there we go, okay. I always wind up moving the columns, but there you go. Our neural network 16 has the second best misclassification rate. Neural network 3 has the lowest. So the more layers may be the reason why we have a lower misclassification rate, but also keep in mind that the more layers we add, the higher potential there is for overfitting to the data and not making that reusable to other data sets down the road. So there's for increased accuracy or a better misclassification rate, we still have an alternate risk of overfitting. I'm trying to think of mean words right now. So I'm going to close this and move on. Okay, so for number 5 in the walkthrough, there it is. Primary concern should be if we overfit the model, we will tackle that problem by using the data partition node in the homework. So now I'm going to move on to the lab. And here's where the lab picks up from the homework. Copy and paste your entire decision trees and neural network walkthrough diagram for the classification portion, including the data set, and paste it below the initial diagram. So I'm going to highlight and copy. Then I'm going to paste below. And I'm going to realign. Now, on the second diagram, delete the data partition consenting, I think that means connecting, but I'm going to say delete the data partition connecting the decision tree. So start by deleting that. And then from the sample tab, include a data partition node directly after the data set. So I have to delete these connections as well. And it said from the sample tab, bring in a data partition node. So I bring in data partition, connect it, and I'm going to connect to everything else. And realign. So this gives me what I was looking for. And while I'm here, I will go ahead and take another screenshot, making sure that I can see my name. As the team would say, that's not my name. Nope, what I do? Wrong button. All right, so there's my screenshot. I'll replace that in my notes later.
Hey Tony, can you go to that result of the earlier model, the first model?
Can I do what?
The results. Can you go to the results of the model comparison? Yes.
The model comparison result?
Yes.
Okay.
And can you show us that the confusion matrix from that?
Yes. If we go to views and assessment, are you talking about the classification?
No. From the output, expand the output.
Okay, I see. You want to see the confusion matrix?
Yes, because my numbers are like way different. Oh, you're getting the same numbers. But our numbers are like totally different.
Yeah.
If I use that number, the calculation and all, the efficiency and all those calculations will be very different.
But are your numbers within like the same hundreds place? You know, are you looking at, 265? Or are you looking at 600? For if you're looking at true positive for auto neural, what's your number for that?
Okay, let me tell you. Just a minute. I'm just opening.
You're good.
So first, for auto neural, my numbers are like starting with 74. The false negative is 74. True negative 300. False positive 0. And the true positive is 626.
Okay. Well, I mean, aside from the false negative,
yeah,
we're very close with the other three for auto neural, right?
Right.
So I think as long as we're within a percentage of each other, that's okay. But I like she said, she's not looking at us having the exact same number. She understands that the black box processes inside the training of a neural network are going to give us different numbers. Somebody else out there may have the exact same numbers that you do, but not everybody's going to. Megan and I have some that are the same. Megan and Christian have some that are the same. Christian and Bailey have some that are the same. So it really just, it's going to be kind of a crapshoot, but I wouldn't sweat it too hard. We're at least in those three categories, we're very, very close to each other.
Yes, that's true.
All right. All right. So where were we? We were looking at the lab, got the diagram. Okay, so now we got the screenshot and I got that. Okay. So now number 2, compare the confusion matrices. So provide the event classification table confusion matrix from the walkthrough. So we come up to the walkthrough. I'm going to right click and go to the results. And then I'm going to scroll down in my output and a little farther. There we go. That is my screenshot for number 2. And even if your numbers are different, it's okay. But as long as you have this, you're good. So then for number 3, they want the same thing from the partition data. I'm going to close this. I'm going to come down to my model comparison node for the partition data, right click and go to results. Oh, I didn't run it. That's right. I got to run it. I forgot I started fresh. So since we're working on a fresh diagram, we're going to do everything the way it's supposed to be done, which means you have to wait patiently, pulling your hair, chewing on your fingernails, waiting for some kind of resolution, asking yourself, why did I put myself in this class? How can I get myself out?
Yeah, sounds about right.
It's a great class. It really is. I'm glad that we have the class where we took everything that we learned in Analytics 1 and we're figuring out how to make it, how to use it practically, and how to use this software to do it. That to me is probably the coolest thing about this whole class.
Sorry, I didn't mean to cut you off. I do love learning like the software and stuff, for sure.
Yeah, and the software, I don't know if you guys realize the value of this software. If you haven't worked with it or heard of it before, the SaaS Enterprise is a $36,000 annual license. It's not cheap. And the companies that I've worked for, they only give that license to like one person on a project, and they have to really justify why they want it and what they're going to do with it. So you're learning on probably the most expensive and sophisticated statistical analytics software on the market. And everything that you're learning needs to go on your resume if you haven't already started doing so. Because like she was saying, just understanding rock curves, understanding these models, understanding how to look at contingency tables, confusion matrices, and making decisions based on that, and looking at your misclassification rates. Everything that you're learning needs to go, basically put it this way. Every chapter objective is a resume bullet point that is going to differentiate you and make you more marketable to your employer and to future employers. So don't be shy about it. Everything that you're learning, put it on your resume. Every time I do that, I start getting more recruitment calls. I was telling a couple of the others, I got a recruitment call from Facebook the other day because I put some of the stuff that I'm doing here, and all of a sudden, bam, it triggered one of their algorithms. Like, hey, we're looking for a data scientist with data mining capabilities, and we want to talk to you. So that's all I have to say about that. Where were we in this? So this is the confusion matrix. That's your overall your model comparison confusion matrix. But yeah, and that's going to go in that part B of your number 2B. So then number C, letter C, number 2, letter C. This is where it starts talking about the calculations. So taking those 2 confusion matrices that we brought in before for A and B, A is our walkthrough model, B is our partition data model. We're looking specifically in C for neural network 3, differences between partitioned and walkthrough data. So we're looking at these rows just by themselves. And using those rows and our calculations for accuracy, specificity, and sensitivity, this is how we get those calculations. And I'll just leave this up here. Does anybody need help on walking through these calculations? All right. Then letter D wants to know about the impact that of the percentages in the classification table between the two models. So the classification tables. If I open up, go into the walkthrough, model comparison node, and going back to my results, I'm going to come up to view, come down to assessment, and go to the classification chart. And then I'm going to expand it. I'm going to drag it out and down so that we get all 9 of these charts. And then that's my screenshot for the walkthrough for 2D. And don't forget to come down here to go to graph properties and change your footnote to your name and click OK. And then now your screenshot ready.
Tony, did you put that screenshot under 2D?
Yes.
Okay, and that's through the partitioned data, or did you do it for both? You did it for both.
Well, I did it for walkthrough and then I did it for partition.
Okay.
It didn't say to do that, but I figure a picture is worth 1,000 words, and I only had like 23 words, so the pictures are the other 987. Is that right? Is that good math? Or 77? 77. So that was the classification chart for the walkthrough data. And then I did the same thing for the model comparison for the partition data. Go to model comparison, go to results, go to view, assessment, classification chart, and then drag it out. And if I drag it down, it just changes the height. That means there's no lower tier of charts. So this, again, changing my graph properties and adding my footer. Now it's ready for a screenshot. And that would be my other screenshot for my partition data in number 2B. So then going to 3. Question number 3 says, open the partition decision tree 6 branch 20 deep. Partition data is the lower. 6 branch 20 deep decision tree is the one I have up here. It's the top of my diagram. I'm going to open the results. And it asks for how many total nodes are in the tree diagram. So I pointed out earlier, this is the tree diagram. This one down here in the lower left is the tree map. So if I open up the tree diagram, I am only showing 1, 2, 3, 4, 5, 6, 8. What happened there? Different model. Let me see. What did I do different? Did I need? Oh, you know what? I didn't run. Oh, okay. Okay. I have to run all these because I didn't run them. I didn't run them against that control point from the earlier. I'm rebuilding all this without the control point. So I'm just going to run them all real quick and then rerun that model comparison. That may have nothing to do with it since I was looking at one node. Interesting. What is going on there? Partition data tree, 6 branch, 20 results. Why am I, okay, let me look, let me go back to my variables here. Rejected, 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 target. No, ordinal, binary, binary, nominal, interval, ordinal, nominal, ordinal, nominal, interval, ordinal, binary. That's all right. Let's look at you, edit variables. You're all in there. There is no tree on the model comparison. 6 branch 20. You know, okay, did I do that? Is it set up right? If it's 6 branch 20, 6 branch 20. And 2 branch 6, 2 branch 6. If I open up my other Lab 5 neural networks, let's look at 6 branch 20. All right, that's my 6 branch 20 from my homework from the lab. So we'll just go off of that. But again, even though the node ID goes from 1 to 24, there are only 19, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's why I theorize that there were 24 nodes overall, but some of them got pruned back to the point where we have just 19. So if we close that, oh, I should have kept it open. 3B is asking for a screenshot of the tree map for this analysis. So if I come back to 6 branch 20 and do my results, then I'm going to take a screenshot of this tree map down here. And that would be my image for 3B. So number 4, open the model comparison node, which compares all of the walkthrough models, which is this one right here. I'm going to open the results. And it says, what is the model description of the best model according to misclassification rate of the test data? So AutoNeural is shown as the optimal model, and the misclassification rate is the best, in my case, 0.003. Again, don't worry if you don't have the same numbers, just that number is the one, whatever number you see is what you need to put down there for that answer. And then wants a screenshot of that model selection. So I just took a screenshot of what you see here.
Tony.
Yes.
Sorry to cut you off. I'm going to assume Bailey's still having the same problem. Bailey and I, whenever we run this, for the test data, we are not getting misclassification rates for the neural network nodes. So the 3, we're only getting test misclassification rates for the branch, the 6 branch, 2 branch, and interactive trees.
Okay. I see. This is where the instructions are very non-specific, because the diagrams show that there's, keep it on train. And if I go to exported data, it has training data, it has rank data. It doesn't show test or validation data for that top model. If I come down here to model comparison and look at the exported data, that may be too far out, but it shows I have train data and test data. Let's look if we actually have test data. Yeah, we do have test data. So because we were not specifically told to change this to a test selection table, and this one, it shows that we were, I'm assuming that we're not going to be dealing with that. This may be a copy and paste error in the instructions. That because we have the test down here, it was somehow applied to this up here, but that should still be trained. And until we get clarification, otherwise, we're going off an assumption. Now I can send her an email and asking her for clarification on that. I can't guarantee that we'll get an answer back in a meaningful amount of time.
I have a question. Did anyone else get different models for the last couple questions? Like your partitioned model gave you different, it selected something other than AutoNeural for the best fitting model of the test data?
Well, are we talking about for this partition configuration down here, Bailey?
Yeah, I'm getting different neural networks as the best fitting models, and I'm just not sure if I was making a mistake. I know that she said one of the purposes of this was to prevent overfitting models. So I didn't know if maybe the idea was to get different models once the data was partitioned and tested on test data, or if we were supposed to have the same.
Well, if I'm understanding your question, the walkthrough diagram, the walkthrough models gave an AutoNeural as the best, but okay. I got neural network 3 as my best network for the partition model.
Okay, I think I did too. Is that the 16 one? Neural network 16?
You know what?
Sorry.
let me pull those results up. But for the model comparison, why aren't you letting me? Oh,
it might already be open.
No, it's all selected. I had the whole thing selected. So for neural network 3.
Oh, the 3.
Yeah, the 3 is showing as the optimal model.
Darn, I had 16.
I got 3 as well.
Okay, I'll keep working with it.
Do you want to share your screen and we can take a look at how you have it set up?
Let me take a look at it first. Now that I see that, and just make sure I'm not super confused before I share.
Okay. Fair enough. Well, let us know, and we'll come back and we'll walk through yours specifically. Okay.
Okay. So back to number 4 real quick. Sorry.
That's all right. Hey, Jordan.
He just woke up and I'm trying to feed him. Okay. So for number 4, you're using the train misclassification, not the test misclassification. Is that where I was getting confused?
Yes.
Okay.
Number 4, we're up here. Number 4A.
Yeah. So then number 6 is comparing the train data for both models, essentially.
It's comparing the model comparison output.
Right.
For both models, yes.
Right. Okay. So that's where I was really confused in number 4. So Bailey, are you showing misclassification rates for train for all of them?
Yeah, let me share my screen. I think I found it. I feel a little bit less lost now. Let me find my sheet. Is it sharing?
I see your lab document.
Okay, that's good. So do you see how this says fit statistics for the test misclassification rate?
This is question 4.
Yeah, that's the screenshot that I had.
And mine says 6 branch 20 deep, and so I put that here.
Mine says 6 branch 20 deep on that, but whenever you look at the fit statistics like the other one, mine shows tree, or the 6 branch, sorry. But is that?
But test data fit statistics, I mean,
yeah,
I feel like.
Is that going off of the test misclassification rate? I don't know. Mine's showing the same thing, Bailey.
Okay. I mean, I'm feeling pretty confident about this part. Just because I think she's trying to get us to realize like how the data partitioning ultimately proved that whatever we did first overfit. Like maybe the neural, the autoneural overfit, which might be okay sometimes, but ultimately, once we partitioned the data and looked at the test set, we found out that it actually wasn't the ideal model.
Do you have your model pulled up? Can we take a look at your model?
Sure.
I don't
Sure.
think, I think you're right. I don't think it's really a major problem because we're not all going to come out with the same things necessarily. But if there's a difference in how your model is set up compared to.
Yeah, let me know. So this is what I have. Do you want to see my results or?
Let's just see, let's look at the nodes first.
Okay.
I'm still looking at your document. Do you have your?
Oh, it's the wrong window. Let me fix my share.
Okay.
Can you see it now?
Yeah, I can. So let me do a side by side. Okay, so for your top model, you've got your data partition linked to your interactive, your 6-branch, and your 2-branch 6. And then you've got your transform variables tied to your variable selection, tied to your 2 neurals, and your autoneural tied to your, okay, so do me a favor and click on your neural network 3 node.
Okay.
In the top model. We're looking at the top model right now. And then go to network, the network ellipse in your properties.
It popped up on the other screen.
That's all right. And it is set to 3 and no. Okay. So now go back to your model and go to the neural network 16. And it is.
Why is it doing that?
16 and yes. Okay, good. So that's just like ours. And now go to the autoneural. And we're looking at the number max iterations is set to 5. Okay, good. Now go to your model comparison node. Oh, your 6-branch 20 and your 2-branch 6. Can you click on each of those for me? 2-branch. And can you scroll down in your property window? So 2-branch 6, okay. And then go to your 6-branch 20. 6-branch 20, okay. Now run it on your model comparison.
Oh, you want me to run?
Yeah, go ahead and run.
Okay, that's going to take a second.
That's all right. I mean, we got time.
But I think that so the Megan and I think we got that output. That's all in the same output. Like we might all have that answer, but there's a train, model comparison table, and then there's also a test classification table.
Yeah.
I think on the same output.
This was
well, maybe not for this one because we don't have. Do we have test on this one?
Whenever I look at the train misclassification rates, the auto neuro whatever has the lowest, but it's not putting a Y next to it under selected model because it's classifying it from the test misclassification rate. But if I just look at my train misclassification rates, the auto neuro has the lowest.
Okay.
If that makes any sense.
No, I mean, what is sense these days? I mean, it's telling us something.
And what Bailey and I think we're thinking is like literally 4A says, what is the model description of the best model according to the misclassification rate of the test data? So that's where that's why I was looking at the model selection based on test misclassification rate and like the fit statistics. And I don't have misclassification rates for the neural network, the 3 neural network nodes, and neither does Bailey. I have train misclassification rates, which would put the auto neural as the best misclassification rate if you look at that. But the question specifically asks.
Yeah, and you're right, but I'm looking at structurally, logically, we have a training model of walkthrough data and a test model of partition data. So we're not going to have test data up here. We're just going to have training data.
Well, it's going to fit the training data really well, you know.
Yeah, it is. And there's no problem with that as long as you account for that you're fitting training data to be put into test data. It's a segmented approach to neural networking. But can we see your results from that top model comparison?
Yeah, let's see. I might already have it open somewhere, so if it doesn't pop up right away, I guess it's these.
Yeah, let's see that.
Okay.
All right, so here it's showing that your auto neural, and you have the same numbers that she has in the example of 0.074, the misclassification rate.
And those, you know, high numbers here for false negatives.
So you do have a course, your answer corresponds to us as far as the auto neural being the optimal model, and your numbers exactly match what's in the, if I'm not mistaken, let me pull that up. What's in the PDF.
Mm-hmm.
She's got 0.074. Yeah, 0.074, 0.115, 0.23. Your numbers match hers exactly.
Okay.
74, 200, or 300, 0, and 626. So yeah, I wouldn't, that, to me, that should be your screenshot. For
yeah, I think, let me see what I've got here. So, okay, so for the walkthrough models, what is the best? Okay.
Yeah, that's for what? For 4A.
I need to take a picture of that. Okay.
Yeah.
And then I wonder why it refers to test fit data.
So how did you get it where your Y is showing up next to the auto neural?
Let's pull up your model, Megan. Let's take a look at your model.
Okay.
I think I was looking at I was ahead of myself and I was looking at the partitioned one. So I think I just need to move some stuff around. Let me stop sharing.
Even though orientation is going to be important in all this.
Okay, sorry, I'm trying to cut Jordan food. Multitasking, okay.
All right.
So this top one is the walkthrough. So whenever I come to my results, I'll just show this.
Now, okay, hold on 1 second. 1 second. I'm already seeing our top model comparison is set to train, not test.
So y'all changed it.
Well, we didn't change it. We made it match the instructions. So the top one is train and the bottom one is test.
This is the top one. Oh.
Yeah. The partition one is test.
This is probably because I was playing with it whenever we were trying to figure out, me and Bailey were trying to figure that out. So I bet I didn't change it back. This is whenever we talked the other day. This is the exact situation I was in. So I bet I didn't change it back. Ugh.
Well, I think we're gonna find that when we run this, when we get the results from this top model comparison,
I agree.
Show the auto neural as the optimal model.
I think you are correct. I think whenever I was messing with it, going back and forth, I probably didn't change it back.
I'll have to update it.
It's still running because, you know.
It's a Mac.
Yeah, exactly. Pretty much. I wish I could like keep this software forever.
I know.
Okay,
All we have to do is get hired by a company or a university if you want to give it to you.
that's true. I guarantee you where I work is not going to give me access to this. I'm sure somebody where I work
My
has
company will.
access.
I've got a couple other co-workers on other projects that have access to this. So I think I can, if the project will pay for it.
Yeah, I'm sure somewhere in my company they use it, but oh, sorry, buddy.
Bless you.
He was eating. Okay.
Is that the baby equivalent of getting soda up your nose?
Pretty much.
Yeah.
Yay. Okay. So that was
Okay.
the problem. I had changed it and didn't change it back. Okay. Oh, that's not how I stopped sharing.
And now if you notice, I mean, your number, your misclassification rate is more in line with mine than Bailey's.
Please.
Yeah, because you got 0.002, I got 0.003.
Okay. Yep. Okay. That's what it was then. Thanks.
Those are the numbers that I exactly had, Meg.
All right.
Because we're in sync always.
I know. Like you and
At
Christian
least
are like,
know that Matt's so consistent. Christian and I can at least attest to that.
that's right. You are the proving grounds for the Mac. So now the same thing with your partition data is make sure that this is set to misclassification and test, and then you should get the neural network 3 as your optimal model.
Yeah, I already had that one the same.
Okay.
It was
All right,
just
cool.
that one, and I think I really just confused myself the way the question's worded.
Yeah, I know. And considering how many times we've experienced typos or even just faulty instructions, I'm not going to dig too hard because I have other things that I have to do.
Oh, I agree.
I think this is a reasonable explanation of all the nodes in both models. I think we're all generally in line with the numbers that we have. And aside from one screenshot that I am going to go in and update right now.
Okay, this is super minute and it probably doesn't matter, but is there like, would it matter which fit statistics screenshot I put in there? I personally like the other one better than the one that y'all used. I like the ones from the output. It shows the same numbers and same information.
I don't think it has any bearing which one you use.
And it's still the fit statistics. It's not like, because I know she's asking specifically for that, so it's the same thing. Okay, I was just curious.
Yeah.
Which model did y'all have for number 5? Y'all had 3? Neural network 3?
Number 5, I have neural network 3.
Is that the one with 16 or, sorry, I already asked you that, I apologize.
No, it's neural network 3.
With there's one with 3 branches and there's one with 16, and the one with 3 branches is the one. Okay. I need to mess with mine a little bit more. Thank you guys.
In my opinion, that makes more sense because the more layers you get, the more you're going to tend to overfit. So I think the 3 is the best, the best logical explanation.
That makes sense.
And all my formatting got screwed up when I brought that new model. To B, C, D, E, 3, and then 3B. Can I bring that? No. Maybe if I shrink that down a bit. Oh. If I shrink that down a bit. And 4 and 5. I can bring 5 up a bit. And 6. Okay, so now. Okay, I'm happy. Is everybody else happy? Is anybody not happy?
I am happy, but I have a quick question. Can you please go through the, can I see the formatting on your, the data partition, the interactive, and go up a little bit? And for your, I just want to confirm that I'm, the transformation variable, and it just, to just confirm, I just want to see, like, if you go through edit variables and I make sure I say it, because something is wrong with mine.
On the data source or on transform variables?
Both of them.
Okay. On data source, edit variables, this is what I have.
Oh, no, my data source is good now. Data source is fine.
So
For yeah.
transform variables.
Okay, that seems fine. All right, that's fine too. What about data partition? Yep. Okay, that seems fine. I didn't change. Okay. That seems fine too. Okay. I didn't change anything. All right. What about your auto neural? Did you?
The auto neural.
Yeah.
It's
Okay.
still the same.
Okay. It comes directly. Okay.
Yeah.
So, all right. All right. That's it.
All right.
Yep.
Anybody else have anything else?
I still don't have the same result with what you have, like for the practitioner, you have the best model, you have the neural network tree, right?
For this partition data, yes, neural network 3 is listed as the best, as the optimal model with the best misclassification rate.
Yeah, I still have an auto neural, and then for the tree, you know, you have a 19 of them. The node, you have 19 of them, right?
For the tree, okay. Tell you what, Mintu, let's take a look at your. Can you share your?
I can. I'm using two laptop right now. The other one I have to log into the Zoom.
Okay.
But remember that you first time when you click on your model, you have a sit up. You should have a sit a 7 node, right? The first time.
Yes. When we first started, when we brought this over, the original model had 1, 2.
No. I'm talking about the tree. I'm sorry, the tree.
Oh yeah, yes. When I was doing the tree on what was it? 2 branch 6, was it 6 branch 20?
Yes, I think so.
If you're looking at 6 branch 20, yeah,
So
I have that.
Mine is showing 6 branch 2. Did I make a mistake?
Yeah, I have this.
It should be 2 branch 6 deep and 6 branch 20 deep.
Okay.
But this is the model that I originally brought over from my existing homework. So this is the one that I trust. I don't trust that one that I just kind of slapped up there.
Yes. Yeah, the new one, I have the same one with you, but I don't have 19. I don't know how can I, you know, I will play with that later, but I cannot come up with 19.
Yeah.
Did you end up with 24 instead of 19?
Yeah, whatever I have, Tony have right now, that's what I have. I don't have the one that he have, the old one, the old one you have.
Even on my original one, if I go to 6 branch 20, now I'm on this one, I'm only getting.
Yeah, that's what I have right now too.
So it's making me wonder now if there's a.
Don't know what happened.
All right, so you know what? In light of this, I'm going to start over. And if any of you have other things to do that you don't want to sit through this, then I understand. But I'm going to come back here and I'm going to start over.
Maybe you should probably start like importing the entire data.
I'm sorry, I had 2 voices in my ear. What was that?
Go ahead. The person that first talked, you can ask.
Yeah, I was just gonna say that my tree map or my tree diagram for the 6 branch 20, I had 24 nodes in mine.
Now, did you have 24 actual nodes, or did you have nodes with up to 24 node IDs, or in 19 nodes physical?
That's a good question.
Because I did the same thing. I said 24 nodes based on the ID count, but then when I actually counted the tiles themselves, there were only 19 of them.
Okay. Yeah, you're right. It is 19.
Okay, yeah, because my initial reasoning is that they might have started out with 24 nodes, but they got pruned back to 19. But
yeah, that's a good point.
Isn't the 20 deep? Doesn't that mean it can't have more than 20? Is that where where you select the cutoff of how many?
Yeah, and I think it will ultimately end at 20 or less.
Right, that's what I'm saying. Like
yeah.
I think it would have had 24, but we set it to cut off at 20. So the pruning made it to the 19.
The auto pruning function kept the final product under the 20 node limit, or the 20 node limit.
Yeah, that's my understanding of it all, if that helps.
Before we go back really far, would y'all mind looking at my diagram to see why I'm getting neural network 16 instead of the third one? Oh, I'm just really not sure why it's happening. 1 second. Okay.
And this is for which question and number, Bailey?
I think it's for the 5th question. So auto neural was the best one here, and I should be getting to match you guys neural network 3, and I'm getting neural network 4, which for me is the one with 16 layers, and I don't know why my results are showing this. So see, it's telling me this one.
Okay.
And I don't know why.
Let's go back to your diagram. And you've got your 6 branch 20, your 2 branch. I lost your diagram. It's all right.
Yeah, every time I click that network option, it flips back to my screen one for some reason.
All right. Then you've got your variable selection. Can you hit your auto align in your in your lower right hand corner?
Is that this one?
Yep.
Whoa.
Yeah, that's what I'm saying.
Thanks. Okay.
So now you've got your transform variables, variable selection, your neural. Click on your neural network 3 node in your partition model at the bottom. Is it already? Oh, it is already, isn't it? Okay.
This one?
Yep.
Do you want me to open network?
Scroll, network, I'm sorry.
Okay, it's gonna pop off my screen real quick.
That's all right.
This is what that looks like.
3 and no is good. Okay. Now go back and look at the 16. And that's 16 and yes. Okay, that's good. Now let's look at your model comparison node. And that is misclassification and test, which is what I've got. No, I don't. No, wrong. I'm working between too many different things right now and I'm getting different numbers. So let me go back to lab 5 and I have misclassification and text. Yes, okay. So update your model comparison node. And let's go ahead and run it. Did you check your variables?
Mm-hmm.
Okay.
I'm happy to always check again, but I did last night. Okay, my results are popping up.
Okay.
Hopefully it's just fixed now. Oh no.
Neural network 16.
Okay.
Let's
70,
look at
30.
let's go to your data source and let's look at your variables.
Okay.
So you've got rejected on checking, other, and savings, which is right. Your good, bad is your target. And then you've got your interval, nominal, interval, ordinal, interval, binary, nominal, interval, ordinal, nominal, ordinal, nominal, interval, ordinal, binary. So that's all good. Okay.
Maybe it's just our data is different or something.
Maybe.
Well, our
There's
like our
be,
first models were slightly different.
we got the same general result for the first model, and we're using the same data source from that model. So I wouldn't put too much weight on data variance, but
okay.
then the neural networks themselves, they don't really, they're not very transparent with what they do
Okay.
and how they do it.
Okay.
So if this is what you're getting, this is what you're getting. And I wouldn't sweat too much about it.
I agree.
You can justify it. You're doing all this where we have all the same steps, all the same processes. You're just coming out with a different number, with a different answer.
So, yeah, and that's okay with me. I'm satisfied. Yeah. Okay, cool. Thank you.
You're welcome.
All right, Tony, real quick.
Yeah.
I know you're trying to answer the other person's question, but real quick, for number 2, part D, you had put all those graphs for the classification chart, but I think you're just supposed to put the classification charts just for the neural network 3 for from both diagrams.
2D. We're talking about the partition impact between the classification between the two models, right?
Yes.
Yeah, I know. And I chose to put them both up there to show the comparison in the classification table results. But I think if you just did the partition one, you'd be fine.
No, I'm saying that I think you just need to put the neural network 3 classification chart, not all of those.
Oh.
Because it says from the 2 models, not the 2 diagrams.
Okay, well, yeah. I'd rather have it and not need it than need it and not have it in my philosophy. So if you put just the classification chart for the table for neural network 3, I think you'd be just fine. But if you have them all out there, I don't think it's going to be any points counted against you.
Okay.
Because if nothing else, it shows it trending across all the different models that reinforces neural network 3. Okay. Anybody else? Any other questions or concerns? I'm going to look into that tree diagram issue with the 6 and the 19. 19 still seems to be the general consensus, but there's an argument being made right now. I mean, just because of other people experiencing that 6-node tree model. So I'm gonna look into that a little bit more. I don't necessarily think that I need to record that effort unless anybody has anything else they want to go over. I'll probably stop the recording and stay on.
Hey, Tony.
Yeah.
I just want to know that in model comparison, do we select the valid or the test? Validation
the model
or
comparison for the walkthrough or for the partition?
both?
From the, again, general consensus going through the homeworks up to this point, the model comparison node in the walkthrough is training, is the selection table is set to train, and the one in the partition data is set to test. And that's just, the directions are a little bit confusingly worded.
Okay.
But we're looking at the top model as being a training comparison and the bottom model being a test data comparison.
Okay.
All right.
Hey, Tony.
Yes.
I just log into another laptop. Can you walk me through with my
By all
model?
means, yeah, Mintu, go ahead, share your screen.
But I think I have a problem because it's, because it's my tree. I don't know, is it because of that? Because the tree, I just have 6 or 7. And that what you try to do right now? Because you have 19? Okay.
Yeah.
Okay, so I just wait for you then.
Well, go ahead and share your screen, because I mean, I want to see what you have first before I dig into it, because that could be another 2 hours worth of work.
Okay. How can I share?
All right. So is this the this top one here? This is the walkthrough diagram into?
Yes.
Okay. So you've got your data partition, you've got your 2-branch 6, your 6-branch 20, and your interactive. Okay. I would delete that control point.
You're talking about, this is the first one, right? The second one I deleted.
Yeah, but in the walkthrough model,
Uh-huh.
they delete the control points and the model comparisons, and they bring in one brand new model comparison. So
I just deleted.
yep. And then link those 2 nodes to the model comparison. And then do a realignment, hit that little realignment button at the bottom. Oh, no. Yeah, you're just down a little bit more, that little arrow to your left.
Okay.
You see that? Yeah, right there. There you go.
So when I copy and, to submit in the lab, this is the model that I should submit, right?
Yes.
Okay.
Yeah. Now go ahead and do me a favor and right click on model comparison and do a quick update and then run it.
It'll take for a while.
It's okay. It's not that long. Imagine doing it, if you did it by hand, how long would it take? This is relatively, light speed in comparison.
I have too much in this laptop. So run it, right?
Yes, please.
Just don't know why is all of the tree disappear.
All right, let's look at your results.
Okay.
Now, we're not seeing the results window, so you might have to drag it over into another area.
Okay. So which one that you want to see?
The model comparison that we just ran, if we can see the results for that. But we want to look at the fit statistics and the output in particular.
This?
I don't know, because all I see right now is your diagram. I don't know if you have the results on another screen somewhere.
Oh, sorry.
It's okay.
Oh, can you see it now? Oh.
I still just see it. Maybe, do you have two monitors?
No.
Okay.
Sorry, let me see. Okay, I know. Okay.
Maybe if you click say, if you hold down Alt and then hit the Tab key on your keyboard, that would toggle between displays.
Right. You see it
There you
now.
go. I see that. Yep. All right. So scroll up to the top for me if you don't mind. And let's take a look right there. So your auto neural, there it is. Your auto neural is set as your optimal model, which is what we're looking for that first one.
Mm-hmm.
And then scroll down back to that confusion matrix. And right there, you've got your numbers are generally in line with the rest of ours. We're all off by a little bit, but I remember somebody's was almost exact to what you had.
Okay, so that's good.
That's good. Yeah, and I would take screenshots of those.
Okay. Yeah, I can go back and. Okay, so what do you want me to go now?
Now let's close this, and we want to go back to that 6 branch 20 node in that first walkthrough model.
Okay, so go back to the model. So 2020.
Yep. And right click on it and go to results.
The tree.
And I'm not seeing your results. So if
I didn't see it. Control. That is so weird. I can't. Sorry, Tommy, just take over. I mean, I have exactly what you have. The result. Okay. Yeah, I don't know why I cannot switch it back and forth.
That's really, as long as you've got something similar or exact as I have, then at least you know that you're on the right track. So
no, I just have 1, 2, 3, 4, 5, 6, 7, 8 of them. That means that, but you say that in your last model you have 19, but the new one that you have right now is just 8, right? So that's what I have.
okay, then I'm gonna explore that more, because I'm seeing that now all the time with this model, that my 19 is now down to 8. So I'm gonna have to kind of reevaluate, but I'm gonna do that. I'm gonna stop the recording, and we can do that, rebuild everything from scratch.
Okay, thank you. Yeah.
You're very welcome. So thanks for pointing all that out. Does anybody else have anything else new or different to talk about before I stop this recording? All right, then I'm stopping the recording.